All right, today we're going to tackle a problem that has, I'm sure, frustrated almost everyone at some point. The one bad Christmas light that takes down the entire string. And what you might not realize is that the answer lies in the two fundamental ways electricity flows. Understanding that difference, well, it's key to understanding pretty much our entire modern world. I mean, it is the classic holiday frustration, isn't it? You spend all that time pulling the lights out of the box, you plug them in, and nothing. Or maybe just half the string is dark, all because of one tiny burnt-out bulb. Well, that little mystery is exactly what we're going to solve today. So to figure out why one little bulb can cause so much chaos, we need to go back to the absolute basics of how electricity even moves. And it all starts with something called current. So the first concept we've got to get our heads around is electric current. And honestly, the best way to think about it is just like water flowing through a pipe. It's a flow of electrical charge, and we measure how much is flowing using a unit called amperes, or you'll usually just hear it called amps. And this right here shows us the single most important rule of electric current. It absolutely needs a complete, unbroken path to flow. You see it here. The current leaves the positive side of the battery, it travels through the wire, lights up the lamp, and then it returns to the negative side. It's a continuous loop. If you get a break anywhere in that loop, game over. Everything just stops. So we've got this idea of a complete path, right? A circuit. But, drawing out detailed pictures of batteries and light bulbs every single time would get old fast. So engineers came up with a much simpler way to map out these electrical roads. I mean, look at this simple circuit again. You see all the parts. The power source, the path, the thing it's powering, and a switch to turn it on and off. But drawing this is still kind of clunky, isn't it? There's got to be a better way. And this is that better way. We use symbols. This is the universal shorthand for electricity. That straight line, that's a wire. The circle with an X in it, that's your lamp. And those long and short parallel lines, that's the battery. This simple language lets anyone, anywhere on Earth, look at a diagram and understand exactly what's going on. Okay, with the basics down, let's get back to our Christmas lights. It's time to meet the culprit, the reason for all our holiday frustration, the first type of circuit. This is a series circuit, and really, the name says it all. The components are all connected one after another, in a single series. What this means is there is only one path for the electric current to take. It has to flow through every single bulb to complete the loop. No shortcuts, no detours. And yet, this is exactly where the trouble starts. See, because there's only one path, when a bulb burns out, that tiny little wire inside it snaps, and poof, you've got a gap in the circuit. The path is broken, so the current stops flowing for all the other bulbs too. It's like a domino effect. And on top of that, the more bulbs you add, the more they have to share the power, and the dimmer they all get. So the big takeaway here is simple. In a series circuit, it's all or nothing. It's a single chain, and if one link in that chain breaks, the whole thing is useless. It's just a really fragile system. So, yeah, clearly this is not the best setup for most things. So what's the alternative? How do you design a circuit that's more resilient, that's smarter? Okay, let's talk about the solution. The hero of our story, if you will. A much more robust and flexible way to get power where it needs to go. Meet the parallel circuit. Now look closely at this diagram. Instead of one single loop, the circuit actually splits into multiple branches. The electricity flows to a fork in the road, and it divides itself, with some of the current going down each path. It's just like a river splitting into a bunch of smaller streams. Each one is flowing independently. This design is a complete game changer. Since each bulb is on its own little branch, if one of them burns out, who cares? It only breaks that one path. The other branches, they're totally fine. They just keep on shining. Plus, adding more bulbs in parallel doesn't make the others dimmer. Each one gets the full power it needs to stay bright. Okay, let's put them side by side because the difference is just stark. On the left, you've got the series circuit. It's a one-lane road. One accident and everything is backed up for miles. On the right, the parallel circuit, that's a multi-lane highway. One lane gets blocked, no problem. Traffic just keeps on flowing in the others. So let's just boil this down, shall we? A series circuit has one path. It's an all-or-nothing system, and everything gets dimmer as you add more stuff. But the parallel circuit, with its multiple paths, gives you independent control and consistent brightness. You can see why it's a much more robust and practical design, right?
Okay, now that you know the difference between these two, I guarantee you're going to start seeing them everywhere. So let's bring this back home, literally, because you're never going to look at the wiring in your house the same way again.
So take a second. Think about your own house. When you flip on a light switch in the kitchen, do all the lights in the entire house suddenly turn on? Of course not. Or when a bulb burns out in your lamp, does your whole living room go dark? No way. So based on what we just learned, which one is it? Yeah, you got it. Your house is wired in parallel. Every single light, every outlet is on its own little branch circuit. And that's what lets you turn on the kitchen light without messing with the bedroom. It's why a dead bulb in the hallway doesn't shut down your refrigerator. It's a design that's all about independence, reliability, and honestly, it's what keeps us from going crazy. And, this is not some brand new idea. We've been using these principles for a very long time. I mean, think about it. City streetlights had to be wired in parallel from the very start. Can you even imagine the chaos if one burnt out streetlight took down an entire city block? The parallel circuit was absolutely crucial for building the modern world we live in. So this tale of two circuits, it's playing out all around us, from frustrating Christmas decorations to the very walls of our homes. But think about what's next. We're building these incredibly complex things now, right? Smart grids that route power intelligently, electric vehicles that need to charge up super fast, all the tiny, intricate electronics packed into our phones. What new challenges in directing the flow of power will we face? What comes next? Now that is something to think about.